Namaste. Welcome to this channel Chemistry Made Easy by Dr.ARM. Today we will see the next part of this atomic structure, that is today's point of interest is atomic orbitals and quantum numbers. So here we will see that the atomic orbitals are related closely to the quantum numbers, and we have to see how is this relationship present between the quantum numbers and these atomic orbitals. So we will explain this on the basis of various values of quantum numbers. We have seen the quantum number L, N, quantum number there is L, and quantum number ML. So here we don't need the fourth quantum number, that is ms. Then we will see which atomic orbital is explained by these three quantum numbers. So here first of all we will see the n quantum number, n value 1. When we have the value of n is 1, then L has value 0 because L is equal to 0 to n minus 1. So it has only 0 value. Then ML is minus L to plus L, means ML is also 0, and in such the atomic orbital is 1s. So this is first atomic orbital present closest to the nucleus. So when we see the nucleus, say this is the nucleus, this is the first, means n is equal to 1, then n is equal to 2, then this will have only 1s atomic orbital. Then when we have another value, that is n is equal to 2, the L value is 0 and 1. L value is 0 and 1. When L is equal to 1, ML value is also 0. And in such case, the atomic orbital is 2s. So, when n is equal to 2, there are 2 atomic orbitals. That is this 2s. And when L is equal to 1, the ML will have values minus L, which is minus 1 to 0 and plus 1. So we will have these three values, 0, plus 1, minus 1. Then it will have the atomic orbitals, that is 2pz. Then this is 2px and this is 2py. So this second main shell will have another set of orbitals called 2p orbitals. So it will have 2pz, 2px and 2py orbitals. Means it is not actually here, but we have enclosure in this second orbit. That is, second main shell will contain 2s and these 3p orbitals, which are named as 2pz, 2px and 2py. Then we will go to the next quantum number, that is, so when n is equal to 3, the L value is 0. Then it will have another value, that is means L is equal to 0 to n minus 1, means up to 2. So the first is 0, then 1 and then 2. So it will have only these three values. For 0, it is ML is also 0 because it will have values from 0 to 0. Then this will have minus, or we will say plus 1, minus 1. First of all, we will see one by one. So it will have first value 0, then next value plus 1, and then next value minus 1. So for this 0 it is 3s. For this 0 it is 3pz. Then for this plus it is 3px. Then for this minus 1 it is 3py. So we will have only these three values for this 1L. This one value for L. Now we will see the next atomic orbitals, that is next value for 3. So when n is equal to 3, we have remaining value, that is 2. L is equal to 2. So when n is equal to 2, ml is also having minus L2, means minus 2 to plus 2, start passing through 0. So this is where ml is 0. Then it will have plus 1 plus 2 minus 1 and minus 2. So we can show their atomic orbitals. So when it is 0, the atomic orbital related to this orbital is here 3dz2. This 3 is this number. This 3 is the principal quantum number. Then the 0 ml value indicates the presence of dz2 when it is a part of this L value. And when it is plus 1, it is called 3dxz. 3dzx, we can also say, we can show it as dzx or dxz. We can have any option. Then the plus 2 will have the name of atomic orbital, that is 3dx2 minus y2. 3dx2 minus y2. Then this minus 1 is represented by 3dxz. YZ. This will have YZ value. And minus 2 will have the name of atomic orbital 3dxy. So these are the few d orbitals. And we have last time seen the shapes of these atomic orbitals. So similarly we can have also various shapes of atomic orbitals, that is s orbital, p orbital, d orbital, then again f orbital for next values of n, that is when it is 4. So this is about the atomic orbitals and their relative quantum numbers. Now we will see the next point of this today's discussion, that is fourth quantum number. Fourth quantum number, that is m that is ms, means spin quantum number. This is called spin quantum number. So in order to understand this quantum number, we have to mention here two observations made by made from spectroscopic experiments. The one observation is that observations from spectroscopic methods spectroscopic experiments, we can say. The first observation is that when the emission spectrum, or when we observe emission spectrum of alkali metals, emission spectra of alkali metals, it shows that the lines, it shows that spectral lines split, spectral lines split into two, or we can say spectral lines are doubled. Spectral lines split, that is doubled. So this is observed. This is an important observation. Second observation is that when the alkali metals are showing the emission, when we are studying the emission spectrum of the alkali metals shows emission of certain radiations. So during this process, the emission shows that there is splitting of the beam. There is splitting of the beam of radiation. From alkali metals. So the splitting of the beam of radiation from alkali metals takes place into two parts. So the beam of the emission of radiation is split into two parts. When it passes through, when the beam passes through, when it passes through a magnetic field. So these are two important observations made during the emission spectroscopic studies. So when the beam of radiation is allowed to pass through a magnetic field, it is found to be splitting into two parts. So these are two important observations, and both of these observations are attributed to the magnetic moment of electron. So why these observations are arising? This is because the electron is said to have some magnetic moment. So we have to observe here why this behavior of electron is specific when it is brought under the influence of magnetic field. So when the electron is observed, we know that electron is a negatively charged species, and every negatively charged species, or we can say any charged species, charged particle is brought under the influence of magnetic field, or in other words, we can say when any charged particle is spinning about its own axis, it behaves like a small bar magnet, because magnetic moment is developed in such electron because it is charged particle and it is spinning about its own axis. So there is development of magnetic moment in the electron. So we will understand this behavior by showing a diagram. So for this, say we will consider this is the nucleus and electrons are present in these orbitals. So if we take, say it is atomic orbital, atomic orbital. So when there is, say, electron is present in the atomic orbital. So this is a part of this atomic orbital and this is the electron. So this electron has its own axis. This is the axis. And when we see the electron is spinning about its own axis in clockwise direction. This is clockwise spin. So electron is spinning about its own axis in clockwise direction. This is clockwise direction. So clock is, the hands of the clock are moving in this direction. So electron, when it is moving in this direction, it has called or it develops some magnetic moment. And in such case, the MS value, that is spin quantum number value, is said to have +1/2. It has +1/2 value. When in another case, if the electron is having opposite spin, so this is another electron, and there it has also the axis like this, and if the spin of this electron is anti-clockwise, spin is moving in opposite direction, that is like this, in the opposite direction of the clock, then it will have the magnetic, that is spin value, magnetic moment value is -1/2. So in this way, we understand that when the electron is negatively charged, means it is a charged particle, and when any charged particle spins about its own axis, it develops its own magnetic moment, and that magnetic moment is important here for showing the spin quantum number value either +1/2 or -1/2 depending upon its direction of spin. Means when the spin of the electron is in the direction of magnetic field, applied magnetic field, then it is +1/2. When the spin of the electron is in opposite direction to the applied magnetic field, then it is called -1/2 value. So in this way, we can explain the magnetic moment value for the electron, that is spin quantum number. Then we will see what are other quantum numbers also in short. So if we take the principal quantum number, that is n. So n is value 1, 2, 3, etc. as we have seen last time. So here this quantum number is mainly responsible for the energy of atomic orbitals. So this is mainly responsible for energy. Means this quantum number explains about the major part or contribution of the energy. Whereas other quantum numbers contribute to the energy in less amount. Then we will see the next quantum number, that is L. So L has values starting from 0 to n-1. The values are starting from 0 to n-1. It is also called Azimuthal quantum number. Azimuthal quantum number or angular momentum quantum number. So it determines angular momentum. It determines angular momentum of the orbit. It determines angular momentum of the electron in space of the atom. In space of the atom. Or so this is also giving some important information, and because of this it explains about the name of atomic orbital and shape of the atomic orbital. So it gives very important information about the name of the atomic orbital and shape of the atomic orbitals. Then next quantum number is magnetic quantum number, that is ML. That is ML. So this magnetic quantum number has values from -L through 0 to +L. So this is magnetic quantum number, and it determines the orientation of angular momentum vector. It determines the orientation of angular momentum vector. It determines the orientation of the angular momentum vector in magnetic field. Means when the experiment is carried out, the source of radiation is placed in the magnetic field, and then we can get this orientation of angular momentum, where it is also called the Zeeman effect. So this is also we have seen in our earlier topic, and we know that it has values starting from -L to 0 to +L. Now the last quantum number, that is which we have seen in earlier, that is MS, that is spin quantum number. Spin quantum number, which has values either +1/2 or -1/2 depending upon its orientation in the magnetic field. When the spin of the electron is in clockwise direction, the value is +1/2. When the spin of the electron is in opposite direction, that is in anti-clockwise direction, or opposite to the applied magnetic field, it is called -1/2. So all these values are considered here. So in absence of magnetic field, when we see the magnetic field is kept absent, then we find that energies of all the 3D orbitals are same. Energies of all the 3D orbitals or 3p orbital, p orbitals are also same. So magnetic field, applied magnetic field, help us to distinguish between or to give the difference in energies of these various atomic orbitals, that is 3D orbitals and these p orbitals present in the atom. So together the quantum numbers NLM and NL and M defines the atomic orbital. Means in short we can say all these atomic number give us the exact address of the electron present in the atomic orbital at a particular point in the space around the nucleus. So we will stop here and we will see the next point in the next lecture. So thank you very much for watching this video. Please subscribe and share this channel. Then like button and press the like button and the bell icon, so that we will bring you the latest information about the new videos added to this channel. So thank you very much. See you next time.